To perform this analysis, it is necessary to find a test phenomenon that, when brought into contact with each of the comparative phenomena, produces effects which are as similar to each other as possible. And if it is observed that a similar effect is produced when the explorative phenomenon comes into contact with the test phenomenon, as well as when the test phenomenon comes into contact with the comparative phenomenon, in that case, it could be assumed that the parts which coincide in both phenomena, explorative and comparative, have the greatest influence on the creation of this effect. However, if it was previously known that the explorative phenomenon contains elements that do not coincide with those of the comparative phenomenon, there would be no need to perform the initial analysis for finding out the discrepant parts. One could proceed directly to the analysis of the coinciding elements. This analysis could also be represented by a similar scheme, except that lines would represent the coinciding parts of the explorative and comparative phenomena. Triangles would represent the discrepant parts of the explorative phenomenon. Circles and squares would represent parts of the comparative phenomenon that do not coincide with the explorative phenomenon and differ from one another in terms of their characteristics. Question marks would represent unknown parts of the explorative phenomenon. In this case, the oval, which represents the result of the effect within the table of the test phenomenon, is common to both phenomena, since it is needed to select such test phenomenon that would create the result of the effect as equal as possible when this phenomenon comes into contact with both phenomena, explorative and comparative, of course. To ensure accurate and correct research results, these experiments should be conducted separately. Firstly, with the comparative phenomenon, and secondly, with the explorative phenomenon. And for each new study, a test phenomenon with an original unchanged composition and structure must be used. Of course, the result of the interaction will never be exactly the same, since the explorative and comparative phenomena contain a certain amount of discrepant components that also partially react with the test phenomenon, creating different reaction products. However, depending on the nature of the selected test phenomenon, the coinciding parts of the explorative and comparative phenomena react specifically with those parts of the test phenomenon that dominate its structure or have the greatest influence on the formation of the phenomenon's main physical and chemical properties, and therefore have the strongest influence on the final result of the effect when reacting with the test phenomenon. The more similar the results of the effect are, the more coinciding elements there are between the explorative phenomenon and the comparative phenomenon, or the larger percentage they account when comparing to the remaining components. Then, by performing a chemical analysis and compiling a list of the reaction products present in the result of interaction between the test and explorative phenomena, and by determining which chemical compounds in its composition are the most dominant in terms of quantity or have the greatest influence on the main chemical and physical properties of the outcome, and by comparing them with the corresponding components from the list of reaction products of the comparative and test phenomena outcomes composition. The majority of them should coincide, and based on the chemical structure of those compounds, it is possible to determine which chemical substances are most dominant in the coinciding parts of the explorative and comparative phenomena, and with which chemical substances in the composition of the test phenomenon they reacted, by creating those reaction products. In order to determine this, the atoms or molecules comprising those reaction products are examined, and then, based on scientific sources describing research-based interactions between various chemical compounds and their results, an attempt is being made to determine what the initial compounds might have been that, upon reacting with one another, produce those reaction products. Once these initial compounds have been identified, an attempt is being made to determine which of them belong to the test phenomenon and which to the explorative phenomenon prior to their reaction with one another. This can be partially inferred based on the known physical and chemical properties of each initial compound, leading to the assumption in which of the phenomena involved in the reaction that compound could have existed in a stable form as one of the composition components and not reacted with the other compounds present in that phenomenon. It is also possible to rely on the known physical and chemical properties of the previously studied parts of the phenomenon or of the phenomenon as a whole, and, based on this, determine which of those parts each of the primary compounds might have belonged to, i.e., the properties of the compound itself must coincide with the properties of that phenomenon's part, or, together with other components present in that part, contribute to the formation of the overall properties of that part. Next step is to sort through the lists and remove those dominant chemical substances which, based on previously known information, belong to the reaction products formed when known coinciding parts of the explorative phenomenon and the comparative phenomenon react with the test phenomenon. Then it would be needed to analyze the remaining dominant compounds, thereby determining the chemical composition of those coinciding parts that belong to the unknown components of the explorative phenomenon. Meanwhile, when investigating those chemical compounds that constitute a minority in the list of reaction products resulting from the interaction between the explorative phenomenon and the test phenomenon, which cause those minor differences in the results of the effects, and which are not formed when the chemical substances present in the known parts of the explorative phenomenon react with the compounds of the test phenomenon. It is possible to determine, accordingly, which chemical compounds are present in the composition of the unexamined parts of the explorative phenomenon that do not coincide with the parts of the comparative phenomenon. Thus, the more similar the outcome of the effect is for both phenomena when they come into contact with the test phenomenon, the easier it will be to investigate the unknown parts of the explorative phenomenon. Furthermore, in order to investigate the unknown parts of this phenomenon as effectively and accurately as possible, it is necessary to get full knowledge about all known parts of the comparative and explorative phenomena. Thus, this scheme can be used as a formula to facilitate the identification of the unknown components of any phenomenon and the investigation of their properties. When a sufficiently similar phenomenon has been found for comparison initially, if necessary, verifying the suitability of the selected comparative phenomenon using the first scheme, comparative analysis for discrepant parts of phenomena, and a test phenomenon that produces a similar effect. Then all that remains is to place all the known information about them in the appropriate sections of the scheme and begin performing the comparative analysis according to the second scheme, comparative analysis for coinciding parts of phenomena. Of course, it is also possible to investigate unknown components without using any comparative phenomenon and only performing the chemical analysis of the reaction products present in the composition of the test phenomenon's outcome. However, In such case, it would be necessary to analyze all the chemical compounds formed after the reaction, then separate those compounds which formed when known parts of the phenomenon reacted with the test phenomenon, and then attempt to identify the unknown components of the explorative phenomenon based on the remaining compounds. Meanwhile, when a comparative phenomenon is used and the coinciding parts of this phenomenon and the explorative phenomenon are identified, there is a possibility that some of them will be among the previously unknown parts. In such a case, there would be no need to investigate them further, only the initial investigations determining which parts coincide would suffice. And it would be sufficient to simply copy the data of their composition and chemical and physical properties from the comparative phenomenon since, as already mentioned, the comparative phenomenon must be chosen with all of its components and properties well known. And it would only remain to investigate those components that do not appear in the list of reaction products of the coinciding and other investigated parts of the explorative phenomenon. Thus, in this case, much less of various tests would be required, which in turn would allow a much faster and more efficient identification of the unknown components of the explorative phenomenon and their properties. To further expedite the testing process, if possible, it is better to select such test phenomenon that does not react with the chemical compounds that predominate in the already known coinciding parts of the explorative and comparative phenomena.